So I just wanted to walk you all through the example problem in your project to let you know what Professor Cahill and I expect. So here's the equation in the example problem. Y equals the absolute value of x squared minus 1 plus 2. My basic function, also sometimes known as a parent function, is y is equal to x squared. So that's going to be the basic graph. I know kind of what y is equal to x squared looks like because we've already done it several times, but it's our parabola. So I'll kind of plot some points here. Here's a 0, 0. I'll label some values 1, 2, 3, negative 1, negative 2, negative 3. Here's 1, here's 2, here's 3, here's 4. So I know that 0, 0 is on this graph because if I plug 0 in for x, I get 0 out for y. If I plug 1 in for x, I get 1 out for y. If I plug 2 in, I get 4 out. So my hand-drawing graph is going to look something like this. Right? I'm just going to connect these. It doesn't have to be perfect, but it looks like a parabola. Something like that. And I'll put 4 on here too. So now I'm going to think about what my first move is that I'm going to do. I've got x squared here. The original equation was x squared minus 1. So that I think is going to be my first move. We've got x squared minus 1. When I'm transforming my graph, I'm going to take my original graph and I'm going to move every point down 1, or I'm going to decrease every y value by 1. So this value, 0, 0, will become 0, negative 1 because I'm moving it down 1. This one, 1, 1, will become 1, 0, and so on. So let me kind of plot my new points over here, moving everything down 1. You can kind of see both now. This is now 0, comma, negative 1. This is 1, comma, 0. This is 1, or negative 1, comma, 0. And then instead of going up 4, I just go up 3, so 1, 2, 3, so I'm like right here. So that's what this negative 1 is doing. It's moving every y value, or it's decreasing every y value by 1. All right. Notice I didn't label the axes here. Let's go ahead and keep going. Now I got to think about what my next move is going to do. In my equation up above, I've got my absolute values. When I apply those to this x squared minus 1, it's going to make every negative value positive. That's what absolute value does for us. So these are all of my negative values here. And it's going to make all of those positive, so it's just going to kind of flip them over, kind of looking like a W. So I'll show you what I mean. These points will be the same. 0 is going to be 0 for y value. This y value 0 is going to stay the same too. So let's go ahead and slide on over. Those zeros, they stay the same. This value of this point 1, comma 3 from the last graph stays the same. Negative 1, comma 3 also stays the same. But the y value of negative 1 is going to become positive 1. And any point that was originally connecting to it, any point in this part will be positive now because that's what our absolute values do. So let's go ahead and come back. Kind of making my parabola, but it kind of looks like a W now. Alright, there it is. That looks alright. Can I make it better? Let's make it better. I don't know if I actually made it better or not. Anyway, I've got just one more move. I could put my last move on this last graph and then redraw the entire graph on the final graph, or I could just go straight from here to my final graph. And I think I'll do that just so I don't have to draw so much. So let's go ahead and go down to the final graph. In my last move, oh, sorry, I didn't write my equation. So in this one here, we've got everything taken care of except for that plus 2. Now I've just got to add 2. And this last 2 is going to take every y value and increase it by 2. So every y value that's on this graph, every point on this graph will just go up 2 units. So this point that is now positive 1 will be up at positive 3. This one that's at 0 will be up at positive 2. this one that's at 3 will be up at positive 5. So I can go ahead and I can do that. I also want to make sure I have my axes labeled on my final graph. So 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. And I'll be a little lazy going this way. I'll just go up by 5. So 1, 2, 3, 4, 5. I'll just label this. That gives me some kind of measure on my graph. Negative 1, negative 2, negative 3, negative 4, negative 5 off the screen, but it's there. We don't actually need it for this graph. So every y value here is going to get bumped up 2. So I had that 1 point right here in my last graph. It's going to go up 2. It'll be right here. I have a point at 1, 0. That's going to go up 2, so that'll be here. This one will go up 2. It'll be here. And the ones at 2, 3 will now be 2, 5. So they'll be up here. Draw my graph again. Draw these sides first because they're a little easier. And my parabola looking like that. That looks pretty good. Yeah, it's not going to win any awards, but it's pretty nice. The last thing I want to do before I check it is I'm just going to figure out the domain and range. So for the domain, I got to think which x values can I use for this function. And I can plug in any value I want into this function because I never get anything tricky, right? I never get anything where I'm dividing by 0, or I'm not taking the square roots, or I'm not restricted by negative numbers. So really I can plug any real number into here. So my domain, if I'm going to write it as an interval, is negative infinity to positive infinity. But my range, that is all the y values that are going to come out. And if we look at the graph, we can see that I'm not going to get any y values below the number 2. The number 2 is the smallest y value I'm going to get. So my range is going to go from 2 to positive infinity because my graph keeps going up forever. So that's how we can get domain and range. The last thing I'd want to do is I just want to quickly check my graph to the equation. So I'd want to take a point. Maybe I'll take this point right over here, 2, 5. 2 is the x value, 5 is the y value. I'll plug 2 into the equation. I'll just do some scratch work over here for my check. Plug in x is equal to 2. And I should get 5 out. So y equals 2 squared minus 1 plus 2. Y equals 4 minus 1 plus 2. And this is going to be 3. 3 is already positive. So we don't really need these absolute values anymore. So 3 plus 2 equals 5. So y is equal to 5. And so the point that I chose just for my check also worked out in my equation. 2, 5, x value is 2. I did all the work and simplified and got 5 out from my y value. And you could pick any point you wanted to. That was just the point I picked. Encourage you to check it before you turn it in too. All right. So if you have any questions, feel free to leave them in the forum. Yeah. All right. Thanks. Bye.